going to go over practice test number 4, which you will be taking on this Friday. I'm going to randomly choose 25 problem out of 69 problem, right? Problem number 1, you have you are moving back and forth 3 times. So 30 times 30 plus 30, which is 60, and 60 times 3, which is 180. You need to find the speed. Speed is total distance over time. The total distance is 180, and the total time it takes for you is 60 seconds. All right. So speed is 3 meters per second. So of course it is C. Okay, that was problem number 1. Now we're going to do problem number 2. So problem number 2. Here's problem number 2. Let's consider two car. Car 1, which moves with 20 meters per second. So this moves with, this is car A, this is DA. This moves with 20 meters per second, and car B moves with 50 meters per second. Okay, and at this time the car 1 meets with car 2, car A. So here DA is equal to DB. So let the car DA is equal to D. If here D initial is 0, here let's say D initial is 200. Okay, so this one has 200 meter head start. Okay, so let's write the equation for this one. The car dA is equal to di plus VIT plus half AT squared. And this one dB is equal to di plus VIT plus half AT squared. Of course, the acceleration is 0 because the car, for both cars, moving with constant velocity. This one di is 0 because we let it be 0. So dA is equal to VIT. VI is 20, so 20t. This one dB is, this one has 20 meter head start, so 200 plus 15t. Now we can set both equation to each other right here. So what are we going to do? We're going to say dA is equal to dV. What does that mean? That means is 20t, dA is 20t is equal to 200 plus 15t. Okay, so now I have 5t is equal to 200, so t is equal to 40. If we plug in 40 over here in this equation, what do you see? You see 20 times 40 is 400, right? So 20 plus 40 is actually 800. So the answer is 800. So how far car A moved from his initial position, which is 0, before it catches the car B? So it moves 800 meters. Okay, that was problem number 2. Now let's go to problem number 3. Okay, so problem number 3. It asks you to find the speed. So speed is now, you know, the distance over time. To be more precise, total distance over total time. Total distance would be 4. And total time would be, you have 5.9 plus you have 6.2 plus you have 6.3 and plus you have 6. So that's what you want to put over here. If you do that, then your speed has to be 0.16 kilometer per minute. Kilometer per minute. Okay, so the answer is, of course, A. So that was problem number 3. Now we're going to go over problem number 4. So let's go over problem 4 real quickly. All right, so now I have 2 vectors. This vector is 90 meter. So something is moving 90 meter, spending 15 seconds to the north. And something else is moving 40 meter, okay, spending 5 seconds. what we want to find is the magnitude of the velocity. First we're going to find the velocity. Velocity is displacement over time. What is the displacement of these two? Displacement of these two would be 90 minus 40. 90 minus 40 is 50. And the time it takes, 15 plus 5 is 20. This is cancel, 2.5 meter per second. That was our question number 4. Let's move to the question number 5. Okay, now we finally have a space to do problem number 5. So you have 2 cars. We have been solving 2-car problem. So we have 2 cars. This car move, car A move to car B. And the distance between car A and car B is 400 meters. Car A is moving with 30 meters per second and car B is moving with 20 meters per second. All right. They are moving to each other, right? So if they are moving to each other, you can add the velocity. What do you want to find? You want to find the time. Time is distance over velocity. Distance is 400 and velocity is 30 plus 20, which is 50. Does it cancel? 8 seconds. Okay, that was question number 5. Now we're going to do question number 6. Question number 6, if you pay attention, you're going to see that which one is constant. This is not constant. This one, if this one is x, this one is bigger than x. This one is like almost 2x. This one is almost 3x. So, no, this is not constant. If this one is 2x, this one is probably x. So, this is not constant. If this is x, this is also x, this is also x, this is also x. This one is good. If this one is x, this is like 2x, this is like 3x, this is like 2x again, this is like x again. This is not constant. So answer to question number 6 is B. Now 7. Like that moves 6 meters north in 2 seconds. So you have 6 meters north in 2 seconds. And then 3 meters east. 3 meters east in 1 second. So we want to find the average speed. Okay, so speed is total distance over time, total time. So total distance is 6 plus 3, which should be 9, and total time 2 plus 1, which should be 3. So 3 goes to 9 3 times, so it's 3 meters per second. And that was problem number 7. Now let's do problem number 8. Problem number 8, as you see, problem 8. So you're going to do it here. This is your initial velocity, and this is your acceleration. And this is your 21 meters per second to the east. This is your final velocity. How far does, okay, so you have to find the distance. So distance, you have to use only one formula can solve this problem. VF squared is equal to VI squared plus 280. Okay, so your VF is 21 squared. Your VI is 15 squared plus 2 times 3D, right? So this is D is equal to 36. Okay, good. And that takes you problem number 9. Okay, problem number 9. A car moves 10 meters per second, right? 10 meters per second. Accelerate. So this is acceleration, okay, while moving a distance of 600 meters. Okay, this is D. The final speed of the car is, so again you have to use VF squared is equal to VI squared plus 280. Your VF squared, that's what you're going to find, final speed. So VF squared is equal to VI squared is 100 because 10 is square plus 2, acceleration is 1.5, and this is 600. So you have 3 times 600, 1800, 1800, 100, 1900. VF is equal to square root of 1900, and which is 44. Okay, so but I want to make sure that square root of 1900 is 44. Is 43.6, so which is 44. That takes us problem number 10. Okay, so problem number 10, a person accelerates at a constant rate as she moves 5 meters along the straight track from A to B as shown in the diagram below. If her speed, so speed, this is speed, and this is also her speed. Okay, how long we are going to find the t given the d? So this is a two-step problem. Okay, all right, so let's first find the acceleration, and then will allow us to find the time. How can we find the acceleration? D is equal to VIT plus half AT squared, and D is of course 5, VI is 2, and then we don't have to use this one, we can use this one. VF squared is equal to VI squared plus 2AD. VF is 9, VI is 4 plus 2. Acceleration we're trying to find, however, D is 5. So we have 9 minus 4, which is 5, is equal to 10A. So acceleration is 0.5. So now let's find the time. Acceleration is VF minus VI over T. So the time must be VF minus VI over acceleration. VF is 3, VI is 2, acceleration is 0.5. So 10 over 5, which is 2. Okay, so answer is 2 seconds. That was problem number 10. Now you're going to do problem 11. Okay, so problem 11, this is initial velocity. This is your acceleration. This is your time. And you have to find the distance. Given that you have velocity, initial time, and acceleration, and you want to find the distance, only one formula I can think of right now, and that is this one. And you want to find the distance. So your VI is 22, your time is 3.2 plus half, your acceleration is 2.4, and your time is 3.2 squared, and that gives you 83 meters. And that one was problem number 11. That takes us to problem number 12. Problem number 12, you have 15 meters per second. This is velocity initial. Deaccelerate. So negative, this is your acceleration, or deacceleration because it's negative. Full stop means velocity final is 0. This is the distance. Okay. VF squared is equal to VI squared plus 280, right? VF squared is 0, VI squared is 15 squared plus 2 negative 7D. So the D is equal to 15 squared over 16 meters. And that takes us to problem number 13. Problem number 13, we have a room below. So this is your initial speed, This is your final speed, and as you see the speed decreases, maybe there is an acceleration. Okay, and one thing you know that velocity cannot decrease if there is no acceleration, but that's not enough. If velocity is this direction, acceleration is this direction, then it is speeding up. If velocity is this direction, acceleration is this direction, then this car is slowing down. Okay? For us, the velocity is to the west, so acceleration must be to the east. Keep that in mind. Velocity is to the west, so acceleration must be to the east. Let's see whether that's the case. Acceleration is Vf minus Vi and t. Acceleration is Vf is negative 23 because it's moving to the west, minus Va is negative 30 over time is 2. So negative 23 positive 30 is just 7 over 2. So 3.5, okay, meter per second squared. So acceleration is to the east because velocity is to the west. Therefore, the car was losing its velocity. If this continues, the car will eventually come to stop. Problem number 14. It takes about the constant acceleration, so either you can choose this 2 point or this 2 point. That's the option you have. So acceleration is Vf minus Vi and Tf minus Ti. Okay, so acceleration is Vf is 7 minus 4, 5 minus 3. So acceleration is 7 minus 4, which is 3, and 5 minus 2, which is 2. 5 minus 3, which is 2. So acceleration is 1.5. Okay. That takes us to problem number 15. Okay, speed increases from 2, and this is the time. What is the magnitude of the acceleration? Okay, so you have to find acceleration. Acceleration is Vf minus Vi over Tf minus Ti. Vf is 9, V is 2.5, and time is 3. So you have 6.5 over 3, 2.2. So acceleration is 2.2. Problem number 16, if you drop something, right? Problem number 16, I took it from Reasons Physics. They made a mistake. If I drop something, here's the graph should look like. All right, this is displacement, time, this is velocity, time, this is distance, time, this is speed, time. The graph should look like, if you drop something, is this. All right. Okay. So to be B is correct, this one has to be not displacement, this one has to be distance, and this one has to be speed, just like this. Or if you have the displacement over here, then it should be like that, and it should be like this. However, in the reasons, you're going to see problem like this all the time. Okay, there is some technical typo over here, but the reason doesn't take consideration of that much technical detail. So when you see a problem like that, then you're gonna see which one is the best option. Although this is wrong, but this is the best option. This is the best option among all 4 choices. This is absolutely garbage. This is worse. This is totally nonsense. There is some technical error over here, but this is correct if you consider, if you let the technical detail go. All right, that was 16. Let's go to the 17. Okay, 17, you have speed of freely falling object and the time of fall of the object near the earth. Okay, so speed, if you drop something, right, speed should look like, not this one, this speed should look like this one, because when you drop someone, distance versus time should be this. So speed versus time should be a diagonal line. So this is the only option, D. Okay, the 18, one thing I'm gonna, 18, one thing I'm gonna tell you that, okay, so this one has two components of velocity, Vx and Vy. This one also has two components of the velocity, Vx and Vy. This Vx is 0. This Vx is not 0. However, Vx has no contribution to the time it takes to hit the ground. Vx play a 0 contribution to the time it takes to hit the ground. So if Vx is instead of like say 10 meter per second, if Bx is 100 meter per second, it's still both gonna take the same time. If Bx is 1000, it's still both gonna take the same time. If Vx is 10,000, it's still, if Vx is 100,000, it's still both, if Bx is 1 million, it's still both gonna take the same amount of time to touch the ground. Okay, I cannot stress this anymore. This is probably gonna be the main misconception for you on Friday. So get over it. Problem number 19. We are talking about that misconception again. You have two stones. I'm going to draw one stone in red, one stone in green. Okay, I have two stones. They are from same height. Height is the same, but one is the red stone, one is the green stone, right? At the same location, right above here. And the size of the green stone is just like the same. The size doesn't matter because Galileo said that, heavy and light objects fall at the same rate, touch the ground at the same time. So initial speed of the red one is, let's say, this one is 30 meter per second, and the red one is 15 meter per second. Okay, so this one is double the velocity. Which one is take longer? If this takes 2 seconds, this also takes 2 seconds. If this takes 20 seconds, this takes 20 seconds. If there's 200 seconds, this takes 200 seconds. What does that mean? That means the horizontal velocity has nothing to do with the Vy, and Vy only affects the time it takes for object to fall. So again, it takes the same amount of time. That takes us to next problem, and the next problem would be problem number 20. Okay, so problem 20, you see acceleration of an object falling freely near the, okay, so acceleration of the object falling, if an object fall near the surface of the earth, this is how the graph should look like, right? This is your dt, this is your st, this is your acceleration versus time, which is actually like this. If dt is this, st is this, at is this, right? Okay, so acceleration is, of course, constant. And how much is that? It's just 10, okay? Absolute value of acceleration due to gravity. And that was 20. 21. Okay. Mass. This is Galileo's big idea. Mass doesn't contribute to the time it takes to fall. All right, and mass doesn't contribute to the velocity of the object. Okay, so object A and object B dropped. Object A has mass m, object B has mass 2m. So this is object A and this is object B. Object B is double the size. Okay, what are the speed and distance of fall of object B after 2 seconds? Same, right? Okay, after 2 seconds, after 1 second, and after 2 seconds. All right, if this one distance is, I don't know, after 2 seconds, 20 meter, this one also 20 meter. If this one velocity is negative 20, this one also velocity negative 20. Same. The mass, small or big, has no effect on velocity and have no effect on distance it falls. Good. That takes us to 22. Maximum height. So to find the maximum height, you're always going to use this equation. Vf is equal to Vi square plus 2AD. Okay, maximum height. You want to find the maximum height. This is the maximum height. So Vf is at maximum height is 0. So 0 is equal to Vi is 29.4. 29.4 square plus 2. Acceleration is negative 10 and D. Okay, so D is 29.4 square over 20. And that is 44. We are moving forward, solving problem number 23. 23 is the concept I'm going to go over right now. So if you are on the rooftop and you want to drop something to the ground, you are on the rooftop, and then object is over here. Object is over here. Okay, object can have many locations, but let's imagine 3 locations. Object is on the rooftop, right? Sitting on the rooftop. Object is in the middle, and object is just before it hit the ground. So one thing you know that total energy, which we call mechanical energy, is equal to potential energy plus kinetic energy. Potential energy is mgh, and kinetic energy is half mv squared. On the top, potential energy is 100%, and kinetic energy is 0%. On the bottom, potential energy is 0%, and the kinetic energy is 100%. Right here, potential energy is 50%, and the kinetic energy is also 50%. Okay, to find how tall the building is, right? Okay, no, we are solving problem number 23, and that is, what is the speed? In order to find the speed, the kinetic energy means speed. So we're going to have to set this to each other. So you're going to write potential energy on the top is equal to kinetic energy on the bottom. Potential energy on the top is mgh, and kinetic energy on the bottom is half mv squared. This cancel. So you have multiply both sides by 2. So you have 2gh equal to v squared. So v is equal to square root of 2gh. And that is A. Moving forward with problem number 24. How tall is the building? So this is exam number 3, problem number 1. Takes 3.1 seconds. So you're going to do the same thing. D is equal to VAT plus half AT squared. And this has no contribution. So how tall is the building? D is equal to half negative 10. T is 3.1 squared. So instead of distance, you're going to displacement, you want to just take the distance. So So you're going to take the absolute value. So d is equal to 5 and then 3.1 squared. So you have 945 because it's 47. So d is equal to 47 meters. That was problem number 24. Now let's do 25. Okay, so you throw down an object just like this. This is dt. You throw down an object just like this, so it's going to look like this. So the velocity graph should look like, if dt graph look like this, velocity versus time would look like this, right? And you throw it down with how much? The speed of negative 0.5 meter per second. All right. What is the speed of the ball? Okay, what is the speed of the ball 0.7 second after it release? Okay, so what do you want to do? You write Vf is equal to Vi plus At. Vf, what is the speed? That's what you find. Vf is equal to Vi is negative 0.5 minus 10, and T is 0.7. Okay, so your Vf is negative 7.4. Okay, you take the absolute value and you find the speed 7.4. That takes us problem number 26. What is the speed of 205 kilogram mass after it has fallen freely from rest for 12 meters? It doesn't matter 2.5 kilogram or 25 kilogram or 250 kilogram. They're going to take the same amount of time if they all fall 12 meters. Okay? What does that mean? What is the speed of it has fallen freely? So we're going to have to find the speed. So Vf is equal to Vi plus At. Now, to find the speed, we have to find a few other things. We have to find the time. So D is equal to half At squared, right? What is the speed of 250 after it is fallen freely? So D is 12 or negative 12, negative 5 T squared. All right. So T is the square root of 12 over 5. So T is 1.5. So T is 1.5. So VI is, what is the speed of, okay, so VI is 0, minus 10, 1.5. So VF is, of course, 15, negative 15. But it said, what is the speed? So you take the absolute value. So your answer is 15. Okay. Now we're going to do 27. A rock falls from rest of a top of a building. How far has the rock fallen when its speed is 39.2 meter per second? How far does it fall when the speed is? So you have to use two formula. Vf is equal to Vi plus At, and you have to say how far does it fall in. So when its speed is meter per second. Okay, so we have to use Vf squared is equal to Vi squared plus 280. All right, it'll fall from the rest. So fall from the rest means this one, and Vf squared is how far does the rock fall when its speed is so 39.2 squared is equal to 2. Acceleration is negative 10, and D. All right. How far the rock has fallen. Okay, so you have d is equal to 39.2 squared over 20. So I have 39.2 squared divided by 20, that would be 77, which is 78.3. Okay, great. Moving forward, we're going to do 28. Okay, so 28, to do 28, object falls freely from rest near the surface of Earth. What is the speed of the object after having fallen distance of 4.9 meter? Of course, speed, all right. So, you know, if it falls 1 second, at 1 second, it can fall 5 meter, and is the speed gonna be -10. All right. So then 4.9, I use -10, but if you use 9.8, -9.8, then it falls 4.9 meter, and of course your velocity would be -9.8. How? Okay, how are you gonna find the velocity? Okay, so let's do the d. D is equal to half at squared, and then d is 4.9. This is of course they are using 9.8, so let's use 9.8. So this is 4.9 t squared. So t squared is equal to 1. So t is equal to 1, right? So then Vf is equal to Vi plus At.
This afternoon is the first day of Broken Technical High School's club fair. I've got some important information for everyone in the building, so please listen up. Ready? Here we go.
So 9.8.
All club
Okay.
immediately
All right, very
follow
nice.
this period. Please
29.
report directly to your advisor so that you can go set up your locations. Club presenters, go to your advisor, set up your locations. Number 2, all representatives of clubs
50-meter high building.
should report to the basement north side to meet with Ms. Robinson Final and members of the
Kicks the stone at horizontal speed.
what's going to happen on Friday.
Stone.
Number 3, all students attending the club fair. Again, if you're attending
Horizontal velocity.
report to the auditorium for some important information and instructions so that you can find out all about the club that Brooklyn Tech offers.
Horizontal velocity 4.
Anyone who doesn't fall into any of those categories, you will be sweeping the halls and be expected to exit the building because all
You want to find the time.
activities that are not connected to PSAL are canceled today. Again,
Okay.
if you do not fall under one of these 3 groups, presenting the club, working the haunted house, or attending the club fair, we need you to
This is -5t.
exit the building because all after-school activities not associated with PSAL are canceled today and tomorrow. Thank you. Have a great afternoon. We'll see you at the club.
Okay. And then now we're going to do 30. Let's do 30. We can completely ignore kilogram because Galileo said, you know, heavy object and light object fall at the same rate and touch the ground at the same time. It doesn't matter what you're dropping. So a 5 kilogram object, starting from rest, falls freely 22 meter in 3 seconds near the surface of the planet. Okay, compared to the acceleration due to gravity. Okay. All right. So now we want to know it fall freely 22 meter in 3 seconds. So d is equal to half at squared, right? It's fall freely for 22 meters, so -22, and half a and t is 3, so 3 squared is 9. Okay, so what do we know? multiply both sides by 2, so you get 44, right? Negative 44 is equal to 9a. So a is equal to negative 44 over 9. So negative 44 over 9 is 4.9, I believe. 4.9. Negative 44 divided by 9 is 4.9. So acceleration is 4.9 on this planet, which is half of 9.8, which is half of 9.8. Okay, that is problem number 30. And we're going to do problem number 31. Okay, so what do we need to find? We need to find how much time, okay? What would be the elapsed time for this object to fall? So again, d is equal to vit plus half at squared. This is y, this is y, this is y. This is negative 50, this is 0 because vx is 4, vy is 0, okay? And this is of course negative 5 t squared. So t squared is 10, t is 3.19. Okay, that was problem number 31. We're going to do problem 32 now. 25 Newton. Newton is the SI unit for force. Okay, so force equal to mass times acceleration, or force sometimes called weight. Weight is equal to mass times acceleration. Okay, so mass is weight over acceleration. Weight is 25. Acceleration due to gravity is 10. So it's 2.5 kilogram. So 25 Newton is 2.5 kilogram. But Galileo said you can ignore how much mass. Nobody cared about how much mass because heavier and light objects fall at the same rate, touch the ground at the same time. So you didn't have to convert Newton to kilogram. Okay, you know that it falls for 1 second. What is the total distance does it fall? Of course, less than what is the total distance does it fall at the end of 1 second? You know, 5 meters, but let's find out. D is equal to vit plus half at squared. This is y, this is y, this is y. Vi is 0 because you don't care about initial velocity is 0. So dy is equal to negative 5 1 squared, which is negative 5. Okay, that takes us to 33, problem number 33. Rock falls from rest, vertical distance 0.73 meter. Okay, it takes 0.63 second. The magnitude of the acceleration due to gravity on that planet. So you have the distance, you have the time. So you're going to find the acceleration due to gravity on that planet. So d is equal to half at squared. Good. D is equal to negative 0.72 and half acceleration you try to find 0.63 squared. So acceleration is 3.6 on that planet. Okay, and that takes us to 34. 34 would be right here. An astronaut is standing on a platform on the moon, drops a hammer, right? If hammer falls 6 meters vertically in 2.7 seconds, what is the acceleration? Again and again, same problem. D is equal to half at squared. Hammer fall 6 meters, and you want to find the acceleration due to gravity on the moon. If it falls 2.7 squared, so acceleration is negative 1.6 meter per second squared. You take the absolute value, and that gives you 1.6. Number 35. Number 35, you have 1 kilogram ball drop from rooftop of a building 40 meter tall. What is the time it takes? It doesn't matter 1 kilogram fall or 2 kilogram fall, as long as it falls from 40 meter. We know D is equal to half at squared, and then negative 40 is equal to negative 5t squared. So you have t squared is equal to 8. So then t is equal to less than 3, which is 2.9. 36, I'm going to probably do until 38. So 36 is astronaut drops hammer 2 meters above the surface of the moon. If the acceleration due to gravity is 1.62, how long does it take? Again, you're going to see, you're going to solve this problem. T squared is equal to 2d over acceleration. T squared is equal to 2d. 2 times 2 is 4. Acceleration is 1.62. So time takes is 1.6 seconds. 37. Ball is thrown horizontally as a speed. So this speed is Vx is equal to Vx is equal to 24, and Vy is equal to 0. Time is 4. So we want to find the height. So d is equal to a half, or maybe Vi yt plus half ayt squared. Vyt is 0. We are find the distance half, negative 10, and 4 squared is 16. So this is 8. So d is negative 80. Okay. 38. This is the 38 is the last one, and that's it. That's it. So pay attention to 31, 38, because probably 38 gonna be on the test. Okay, so 38, I want you to find they ask you to find, okay, so I want to find the acceleration. To find the acceleration, I want you to convert it to VT graph. So the VT graph for this one would be this, okay? And VT graph, okay, so let's use the different color. This, okay, that is this. And this is this. This is this. And this is, I'm going to use blue. And this is this. And this is this. And this one, I'm going to use, I don't know what color I have now. I have red again. Red. And this is this. Okay, good. So now let's find this one is how much? This one is 8 minus 0 over 4. So 2. This one is 2. Let's find this one. We cannot find this one, so we know this. We know this. We know the half of BH, and if we know this, we know the other one. Okay, so we know that A is equal to half BH. So A, what is the A for this one? A is the distance. Distance is half, base is time, and this is velocity. So the distance is 8. 8. Half. Time is 2. And velocity. So it's 8. So you're going to write 8. And then this, if this is 8, this is negative 8. Okay, good. Now we're going to find the acceleration. Okay, to find the acceleration, what are you going to do? Let's see, convert it to AT graph. So I'm going to convert it to AT graph. Maybe I'll convert it to here. So convert it to AT graph. Okay, so this is going to be easy. This is going to be this. This is also easy. This is this. Okay, this one is this. Okay, now what is the acceleration? Let's see. Acceleration is velocity final minus velocity initial over time. What is the velocity final? Velocity final is negative 8 minus velocity initial is 8 over time. Time is 10 minus 6, 4. So negative 16 over 4. So negative 4. Negative 4. All right, I'll see you tomorrow, everybody. Please study. Tomorrow, you're going to be studying. We're going to be doing problem number 39 to 69.